When we've been evaluating expressions or building equations, we've used our order of operations, and the way that we've remembered it is by the acronym GEMMA. And so it only makes sense that since when we solve an equation for the variable, the way that we do it is by working backwards. We're going to use the aid of GEMMA to solve equations. However, we are going to be working with GEMMA backwards. So instead of writing GEMMA going down, I'm going to write GEMMA going up, because we undo each operation in the reverse GEMMA order. The last thing we did is the first thing we undo. And so in our first example, 5x minus 2 equals 18, since we're working backwards to find the value of x, we're going to first look for addition or subtraction. Okay, so first let me get my railroad tracks down here to separate my sides of the equation, and let's work on isolating that variable. The last thing we did was to subtract 2. It is the first thing we're going to reverse. So we will be adding 2 to both sides. Whoops. And when we do that, we are going to cancel out minus 2 plus 2, and we are going to have 5x being equal to 18 plus 2, which is 20. Okay, we're done with our addition. And now our next step is to undo any multiplication or division. Well, I do have multiplication. 5x is actually 5 times x. And so how do I undo multiplication? By division, and the way that I'm going to write it is with a fraction bar. And we always, in order to undo multiplying a variable by its coefficient, we always divide by the coefficient of the variable. Why? Because that makes the coefficient 1. And that's what we want, because 1x is the same as x. So x is going to equal 2. We had to do the same thing to the other side to keep our equation balanced. And 20 divided by 5 is 4. So x equals 4. Now let's do our last step, which is to check. And so we have 5x minus 2 equals 18, and put your multiplication dot. 5 times 4 minus 2 equals 18. Now we will follow our GEMMA the right way because we are evaluating this. 5 times 4 is 20, minus 2 equals 18. 18 does equal 18, and you give yourself a big pat on the back. Okay, so that's one instance where we're solving a two-step equation. Now let's look at this other one. It looks a little different, and you can see that we have multiplication, which is the 2n or 2 times n, and then we have division. Well, that sometimes happens in an expression when we're using GEMMA to evaluate, and we know that we go from left to right. The first thing that we see when we have division and multiplication in the same expression, what did we do? We went from left to right because one is not more important than the other. So let's do our GEMMA backwards. Okay, there is no addition or subtraction. There is multiplication and division. And if you think about what we did to the variable, okay, remember a fraction bar is like parentheses. It's a grouping. So this 2 times n is a grouping, and you see the G for grouping is all the way at the end. So we can think of it that way. Okay, and so what did we do after we multiplied? Then we divide by 3. So what we're going to have to do to undo dividing by 3 is multiplying by 3. And what happens? The 3's cancel out. Wait, let me put my railroad tracks. The 3's cancel out. And what do we have? We have 2n, or 2 times n, equals 4 times 3, which is 12. And how are we going to work on that? Well, we see that the next thing is multiplication that we're going to undo. And we undo it by dividing. And we said in example 1 that we divide by the coefficient of the variable, and that would be 2 to make this 1. And then we have n is going to equal 12 divided by 2, which is 6. Well, let's do our check. We need to give ourselves that pat on the back. 2 times n over 3 equals 4. Okay, substitute in 2 times 6 over 3 equals 4. 2 times 6 is 12. 12 over 3 equals 4. 4 does equal 4. And give yourself a pat on the back. All right, now, this is a different kind of a two-step equation. It looks like we're only doing one operation. We're dividing 6 by an unknown number, by n, and then that should equal 2. Why is this a two-step equation? Because what can I do to get n by itself? Okay, I have a division problem, but if I multiply by 6, that's not going to get rid of the distraction. That's not going to isolate the variable, because I'm not dividing n by 6, I'm dividing 6 by n. And that looks kind of like a strange situation until we realize that we can do anything to one side of the equation as long as it's done to the other side. And that includes something you may not have seen, which is actually moving the variable from one side to the other by adding or subtracting or multiplying or dividing. Okay, we haven't done that yet, but we can. And so what I'm going to do here is I'm going to show you that what can we do? This is actually 6 divided by n equals 2. Okay, and how do I undo division? By multiplication. What do I have to multiply by? Whatever the divisor is, right? So I have to be able to say, okay, 6 divided by n times n, and this is what's going to cancel out. And then I have to multiply this by n as well. So this is going to cancel out, and it's going to give me 6 equals 2 times n, or 2n. And the way that I'm going to write it in my equation is like this. I'm going to multiply both sides by n, because again, I'm trying to get that 6 divided by n times n, because we know that will cancel out. So I'm going to cancel these out, and that leaves me with 6 equals 2n. Okay, and now how do I undo multiplication? By dividing by the coefficient, which is now 2. And I have to divide the other side by 2 as well. Cancels out, and I'm left with n equals 6 divided by 2 is 3. And this is one of the reasons that we always check, because this is a little more complicated and we want to make sure that 3 is the correct value of n. So I'm going to check by substituting. So 6 over n is the original equation, equals 2. And if n equals 3, 6 over 3, or 6 divided by 3 equals 2. Does 6 divided by 3 equal 2? Indeed it does. So 2 is equal to 2. And especially with this equation, which was a difficult one, I definitely want to give myself encouragement. I want to give myself a big pat on the back. And that's how we do multi-step, but especially two-step equations. Don't be afraid of it. Just know that you can move anything around. You can do anything to one side of an equation, including subtracting, adding, dividing, or multiplying with that variable, as long as you do it to the other side. So if you need to move the variable from one side to the other of the equation, you are just going to undo that operation, and that will move the variable.